So one of the things that's happened is, in our field is we deal with change all the time. And because we deal with change all the time, we have to get more productive. And we're going to talk about doing that. Basically, it's Moore's Law. We're this field that we expect things to double every couple of years. No other technology does something like that. It's been going on for decades. So what that means is the hardware designs get bigger, faster processors and bigger memories, which means software gets bigger because it's faster and it has a bigger footprint. And so what we've had to do is improve software productivity. So how much bigger is it? 50 years is, it's 1,000,000 times more cost effective, 1,000,000,000 times, so giant numbers, right? So suppose we were still writing software the way we did 50 years ago, it would take infinity to write a big, 100 million line piece of software, but we have tools that let us do that today. So there's really four techniques. There's just four techniques that people are using. First of all is making it concise by writing in a short amount of information. They get transformed into big amounts of information. That's a good way to be more productive. Code synthesis, you don't even write it. It gets generated for you. Reusing stuff that's already been built, that's a big way to improve productivity. And finally, automation and tools. So let's just go through those. So the first one is conciseness. So this line here that you see, that's one way to write that, right? That there's some languages is that the way you would write it, but a much more compact version is this, and this is legal Ruby, right? A should be greater than or equal to 7. You can just kind of read it and understand it. So that's shorter, fewer characters, and it's easier to understand. So that's an example of clarity being conciseness. In general, it's an example of raising the level of abstraction. That's why high-level languages were invented. Other ideas like automatic memory management, 30 years ago, my friends would argue, that automatic memory management didn't save you that much, there weren't that many bugs. Now we know that in languages like C, there's lots of bugs if you manually do management. And these scripting languages like Ruby have these ideas of reflection and metaprogramming, which raise the level of abstraction. Software synthesis is this idea that you generate the code that you're going to use rather than write it yourself. An example is BitBlit, which generated code to fit the situation. So rather than having a loop in there to do bit movements, a little if statement in it, it would generate it to the situation so the if statement didn't have to be in there. And that was the first example of that. And right now in the research, and even in products right now, there's programming by example. So if you got the latest version of Microsoft Excel, you can give it an example of what you want it to do, and it will create a macro to do that for you. So we're starting to see code synthesis really happening in products. Reuse is, of course, people from the very first computers have wanted time to do that. Why do we have to write everything ourselves? Why can't we reuse the code that we already had? So the first were procedures and functions. Almost from the dawn of computing, we had that. Standardized libraries. Once we had functions, then we'd create libraries so lots of people could use them. Object-oriented programming came along 20 or so years later that we can put together collections of tasks. And then design patterns, and we'll talk about, there's a whole chapter on design patterns in the book, and we'll talk about in this class, is that there's a strategy that you can reuse even if the implementation varies. The final topic is automation and tools. I think of tools as kind of what computer scientists do. Is that we see a problem, it's tedious, let's build a tool to make it easier to use. In fact, that's a lot of what you'll be doing in this class. A lot of what you'll be doing is exactly that. Some Rails programmer found something that was tedious to do and built a tool because it's kind of easy to build tools in this environment, and suddenly it's a tool we use. I think this is the 5th time we've taught the class in the last 5 years. Every time we've taught the class, there's been some new tool that we had to use that wasn't available last year that we can't imagine how to use it without it. So one of the problems is lots of programmers are coming up with tools. All kinds of programmers are coming up with tools. So are they dependable? Does it have a good user interface? How do you pick from them? Well, we're going to help you in this class as Armando and I and the staff are going to pick the tools you have to learn. There's a half a dozen of them, but they work and they're dependable. You'll have to figure that out on your own after this class. But as I said earlier, software engineering, because we're in this rapidly growing field, is something that demands lifetime learning, and you'll get an example of that. Lots of examples of learning tools here that you'll come to love, I would say.